An AI gets a hard math problem wrong. You delete exactly one word from its work, hit regenerate, and suddenly it solves the whole thing correctly, every single time.
Hold on, one word? Okay, guess along at home. How many words would you need to fix to rescue a broken AI solution? Whatever number you're picturing, it's smaller.
And keep one small thing in your back pocket, a stray 7. One digit sitting in the middle of a math problem. By the end, that 7 is the whole story.
Because this one hits close to home. Every week there's a headline about AI acing math tests, passing exams, and doing your kids' homework. This paper asks a simpler question. When it fails, what actually went wrong?
And the answer breaks the obvious story. Picture a test that ran for about 4,000 hours on some of the fastest computers on Earth. 3 different kinds of mistakes, each with its own cure. And one trap a giant AI falls into exactly the same way a tiny one does.
See, my gut says when AI gets math wrong, it just doesn't know how. A gap in what it learned, right?
That's the natural guess, and it's often wrong. A lot of the time, the model absolutely knows how. Then one bad word at one bad moment sends the whole thing off a cliff.
Off a cliff from a single word? How does that even work?
Think of a chess player in a winning position. Strong player, game basically won. Then one blunder. After that single move, even perfect play can't save them. Before the blunder, almost every path wins. After it, almost every path loses. The researchers went hunting for that exact blunder inside an AI's reasoning, Eric.
And how do you even find it?
At every single word, they asked one thing. If we freeze the work right here and let the model finish 64 different ways, how often does it still land on the right answer? Early on, most of those endings are happy. Then at one specific word, the happy endings collapse. That word is the cliff. And hang on to this. Sometimes the model's best guess was actually fine, and it just got unlucky and grabbed a worse word.
So how do you prove that one word is the culprit, Cassidy, and not just a coincidence?
They did surgery. Take a failed solution, delete only the cliff word, and let the model try again from right before it. If that word really was the killer, the problem should suddenly become solvable. And it was, every single time. Pull the word and the model recovers. Leave it in, and even 64 fresh attempts sometimes can't escape.
Wait, 64 tries can't dig out, but delete one word and it's fine?
That's the result, Eric. So, your guess from the start. How many words to rescue a broken solution? 1. Just the 1. And that stray 7? The model was breaking the number 1092 down into its factors. At one step, it wrote a 7 where the math needed a 3. Before the 7, recoverable. After it, doomed.
And these cliff words, are they all the same kind of mistake?
No, 3 flavors. Sometimes the model's confidently wrong. Sometimes it hesitated and leaned the wrong way. And sometimes it knew the right word and the dice just betrayed it. The strange part? That confident wrong trap? A huge model and a tiny one fall into it on the very same words.
Though, let's be honest about what this is, Cassidy. Finding these cliff words costs a fortune in computing, that 4,000-hour price tag. So right now, it's less a smoke alarm, more an autopsy. It tells you what killed the solution after the fact, not in time to stop it.
Fair point. And catching it live is exactly what they want to build next.
So here's the one to argue about. Knowing a single unlucky word can sink an AI's reasoning. Does that make you trust these systems more or less?
Tell us in the comments. And if making sense of the newest AI research sounds like your kind of thing, subscribe. We turn strange papers into plain stories, one at a time.
Turns out for an AI, the line between right and wrong can come down to a single word.